Good day, everyone. Um, Now we want to look at one of the applications of the process of leaching, and we're going to be looking at the leaching of gold. And as we all know, leaching of gold is mainly done using the lixiviant, which is cyanide. Of course, there are other lixiviants that can be used for the leaching of gold, but as we know, the prominent lixiviant for the process of gold leaching is cyanide. So in this lecture, I'd like you to appreciate the various theories that govern the process of cyanidation. I would also like you to familiarize yourselves with the parameters that affect gold cyanidation process. Okay? Now, just a recap from our previous lecture, we understood that there are different types of lixiviants that are used in the industry, and we gave a few examples such as your cyanide, such as your sulfuric acid, you have an ammonia, and a lot of other examples. And then we discussed that for leaching to be effective, there are certain conditions that need to be optimized. And we are also going to be looking at some of those conditions again as we now further narrow down the process of leaching to this to the gold cyanidation process. Then we also discussed that there are different types of leaching methods, there are different types of classification of dissolution methods, and we gave a few examples that they can be termed reactor based, that they can be termed type of solid based, um, and so on. And we also took note that the important parameters to be taken into consideration when selecting the type of leaching method. You for you to go to decide to take the agitated leaching method, or maybe the VAT leaching method, or maybe the in situ leaching method. There are some factors that you need to take into consideration. So we all covered that in our previous lecture. Now let's go into the cyanidation, which is the leaching of gold using cyanide. Now, before cyanide was introduced, aquaregia was the one that was discovered by a chemistry researcher, Jabi ibn Hayyan, in the 6th century. He is the one who introduced the chemical technology for extraction from the gold ores using what is known as the aquaregia. I'm sure you all know now what aquaregia is. Aquaregia is simply a mixture of your hydrochloric acid and your nitric acid in the ratio of 3:1 respectively. And when you do that, you simply leach your gold into solution and you form your Al, your AuCl3 in aqueous solution. And therefore, this means that you have leached your gold. So he's the one that you um, so he's the one that actually introduced this chemical technology for leaching gold from of ores. And because the technology of using aquaregia was more expensive, and it was also very toxic and difficult to handle, and and a whole lot of other disadvantages. In 1783, in Sweden, um, and also later in Russia, Germany, and England, um, the cyanidation of gold was discovered. The use of cyanide to dissolve gold became very prominent, especially in the 1800s. And the formula that was agreed that was the result for the dissolution of gold was this 4Au, 4 gold plus 8 Cn minus in the presence of oxygen, and then of course there need to be water. You then be able to dissolve your gold. Okay, right. So this was the cyanide reaction that was proposed by several researchers. Okay, but then along the way, uh, there were arguments or further researches or further refinement in the research on how this process goes by, whereby you mix your gold and your cyanide to form this gold cyanide complex. The there are several theories or there are several routes or several stages that have been proposed on how the gold cyanidation process occurs. So basically, the cyanidation of gold is done using a lixiviant, as we said, cyanide. But cyanide exists, or it exists because it's in you buy it in solid state. It exists together with a simple salt. So you find that your cyanide is actually bought or used as maybe your potassium cyanide or maybe your sodium cyanide and, and maybe in some cases, but really your calcium cyanide also. Okay, so this salt is supposed to have a very high solubility in water, so it must be able to dissolve very fast and quick in water, and it must also be cheap and readily available for the process. As you can see here, this is um, the EH-pH diagram for your cyanide water system. For your leaching to be effective and efficient here, we are looking at this region of cyanide to be. That's where we say the most efficient leaching parameter using the cyanide lixiviant exists, because this is where your Cn minus ion is stable in this thermodynamic region of your potential and your pH. Okay, so like any reaction, as we said, leach, leaching reactions we have got your different types of leaching reagents, as we saw again in our previous lecture. They can be redox reactions, they can be simple dissolution reactions. The cyanidation reaction is actually proposed to be both an anodic and a cathodic reaction. There is to be um, exchange of electrons in the system. Okay, so the anodic reaction is simple. The dissolution of your cyanide here, the dissolution of your gold using your cyanide, and then you release an electron is released. And then the supporting cathodic reaction is here, your oxygen and your water reacting together, also in the presence of these electrons being given by this anodic reaction, and then you produce your hydroxyl ions. Okay, so these are the uh, sort of like the final anodic and the cathodic reactions. But as you can see here, there can be also several stages that can occur until you have this final anodic reaction. For example, also on this side, some scholars propose that you first of all, on the cathodic side, you first of all produce a hydrogen peroxide, and after hydrogen peroxide, that the one that is reacts with the electrons, and then you form the hydroxide ion, and then this hydroxide ion, then these two reactions will form the basis of the cathodic reaction. Okay, so these are all proposals or researches what has shown how the cyanidation reaction okay, so this is the overall cyanide reaction as we all know it. Okay, it also can exist in different forms. Maybe it can be a 2 here, 4 here, a half here, a 1 here, a 2 here, and also a 2 here, something like that. But it's the same overall reaction. Now, as I said before, there are various theories that have been proposed to explain the mechanism of gold dissolution in aqueous solution. So we have the oxygen theory, hydrogen peroxide theory, cyanogen formation theory, and also the corrosion theory. Now, these theories are very important for you to know because they give you an idea of what are the steps that are involved in the reaction. There might be a step that is that is retarded, or there might be a step that is affected by certain conditions, and your cyanidation process does not occur as you would want them to be. It is because maybe one of the steps, or maybe it could also be the rate determining step in this cyanidation overall reaction. For you to get there, there might be steps that might need to be altered, or that might need different types of conditions. Okay. Right. So the oxygen theory, which is the most popular one, was discovered by Elsner. So you realize that we call this the Elsner equation. It was discovered that oxygen was very vital for the dissolution of gold in presence of your cyanide. So this researcher is the one that made this discovery that without oxygen, this reaction cannot proceed in the rate that we would want the gold leaching to occur. However, when you put in oxygen, then the rate of dissolution of your gold can actually be much faster. Okay. Then we also have what is called the hydrogen theory. The hydrogen theory simply proposes that your hydrogen gas is evolved during the process of gold cyanidation. So he also proposed that here, when cyanidation progresses, your hydrogen gas is actually evolved. So this is the hydrogen theory by Janine, that was produced just before the 1900. Okay. Then we have what is also known as the hydrogen peroxide formula by Bodlander. He suggested that the cyanidation process actually occurs in two steps. Okay. So the first step, which is this one, is in the presence of your oxygen, you produce this sodium gold cyanide complex. However, it produces it with hydrogen peroxide. Okay. Then it is then this hydrogen peroxide here that will then further react with your gold and your cyanide to produce this the sodium gold cyanide complex. So this is the overall reaction for the hydrogen peroxide. So the difference with this or the further steps that this theory suggests that there's an agreement that oxygen is quite vital, like the previous researcher also. But however, it proposes that in this case now, hydrogen peroxide is the first that is produced, and is actually the one that is responsible here for dissolution of gold into this gold sodium cyanide complex. Okay, so that's the Bodlander hydrogen peroxide. Okay. Right. So here, as we said, hydrogen peroxide is actually formed as your intermediate product. Okay. So he did also his experiments, as I said, and he realized that in the absence of oxygen, the dissolution process is actually very slow. Um, Hence, therefore, the body, he suggested this second reaction, which is the reduction step. Okay. So here, as we said, your hydrogen peroxide and your gold, and then you have got your complex. Okay. All right. Right. Then you have got your cyanogen formation theory. Okay. So a cyanogen formation theory simply also agrees with the other researchers that oxygen is quite important. quite important for the leaching process. However, it says here um, the suggestion here is that oxygen produces cyanogen gas, which is believed to be the active reagent for the dissolution of now of the gold, according to this react. So your presence of oxygen, as agreed, that first of all, here there is no gold that is present in this reaction. So it's simply your cyanide and your water to produce now this cyanogen gas, which is believed now to be the active reagent or to be the one that is responsible now for the dissolution of your gold. So these are the proposals by Christie in the cyanogen formation process. Um, right? This is simply different mechanism. However, you realize that these two stages, they also add up to the Elsner's equation when you also include the other reagents. Okay. Then you've got your corrosion theory. Okay. Um, this is simply a further steps to the Bode-Landers equation, to the Bode-Landers studies, and then it is proposed that the dissolution of gold in cyanide is actually similar to a metal corrosion process in which the oxygen is dissolved first of all into solution and reduced to your hydrogen peroxide and your hydroxyl ion. Okay, according to this reaction here, you've got your oxygen forming your hydrogen peroxide and your hydroxyl ion. Okay, and then here you've got your gold being reduced, releasing an electron here, and then your gold being dissolved here by cyanide to form this AuCN complex. And then you've got your AuCN further reacting with another Cn minus anion to form your AuCN, and then this will be your the overall reaction for the corrosion theory that has been proposed by a researcher called Boonstra. Okay.